Hello dear students. In our last discussion which was of distance time graph, now we have another topic which is velocity time graph. There are few points, important points we can say we have to remember regarding graphs and particularly velocity time graph. First of all, as we have discussed in distance time graph, that we can describe the motion of a body in words, like a car is moving with 20 meter per second, or a body is at rest. And obviously graphs can be useful when studying the motion of a body. As I said that we have discussed the distance time graph, so this time we are going for another set of graphs, which is basically the you can say another way to state or describe the state of a body. This set of graphs is velocity time graph of a body in this case, and obviously here, as we want to draw the graph of velocity against time, so velocity or speed will be along y-axis and time will be along x-axis. Obviously you know that the time is independent quantity and velocity is dependent quantity in this case. These are two basic points which we have to remember. The first is that the rate of change of velocity is obviously termed as the acceleration. Therefore, the gradient of the velocity time graph gives us the acceleration of the body. So this is very important point. Yani whenever we will draw the velocity time graph, the gradient of the graph will be the acceleration of the body. And obviously we can describe different situations where we will have obviously different gradients of the graph, and with respect to the gradient we will decide that what is the state of the body as far as the acceleration is concerned. The second point is obviously the product of velocity and time, and you know that velocity of time or speed of time gives us the displacement or distance covered by a body. So remember this a very important thing, that the area under the VT graph gives the displacement or distance covered by a body. So we have two points again I repeat, that the first one is that the rate of change of velocity is acceleration, then the gradient of VT graph is acceleration, and the area under the curve or under the graph will be the displacement or distance covered by a body. Now we will see different graphs, and we will describe that what is the situation of the state of the body with respect to the graph. Here I have taken you can say sort of data as an example, and the situation we want to describe is that the body is at rest. So what is going on here, what we are observing, for different time intervals 0, 1, 2, 3, 4, 5, the velocity value is always 0. So what we have to do, we have to draw a graph. Obviously the velocity is 0, so the line is along the x-axis, and obviously this shows that you have the situation like this. Observation is graph line is a straight line along x-axis, and what conclusions we can draw simply as there is a 0 value of the velocity. So first thing is that the velocity is 0, and obviously you can see that there is no gradient of this line. So as there is no gradient of this line, therefore the acceleration is 0, or simply you can say no acceleration. 0 acceleration, no acceleration, 0 gradient, no acceleration, or 0 acceleration. The third point which we can say get out of it, that the 0 area under the graph, obviously there is no area under the graph, the line is along x-axis, so there is no area under the graph, so obviously no displacement. And this is very obvious, when there is no velocity the body is not moving, so simply you can say that when the body is not moving, obviously the body will not cover any distance or displacement, so 0 displacement. And simply the ultimate result or conclusion is that the body is at rest. So this is one of the situation. Second is when the body is moving with constant speed. So in this case, what is happening? The time is passing 1, 2, 3, 4, 5 seconds, but what the observation is that there is no change in the value of the velocity. Obviously, there was same situation, there was no change in the velocity of the body, but this time the velocity was 0. But this time the velocity is not 0, but has a particular value, a constant value, which is 20 meter per second in this case. So the graph of this data will be something like this, where the line is obviously again a line parallel to the time axis, but here you have the line which is showing you that the velocity is 20 meter per second, and obviously the time is passing but there is no change in the velocity. So the observation is very simple. Graph line is a straight line which is parallel to the time axis at 20 meter per second. So this is our observation. So when we observe this line, what will be the conclusion? So simply you can say that the velocity is 20 meter per second, which is obviously a constant value, and there is again no gradient or zero gradient, and there is no slope or zero gradient. Zero gradient means zero acceleration again. Actually, we have to remember this point that A is equal to V minus U divided by T. So if U and V are equal, the value of A will be equal to 0. So this is what we have here. A is equal to V minus U divided by T, but as for any interval of time, the V is equal to U, thus what will happen? A is equal to V minus V or U minus U, and you can say that the result will be 0 divided by T, and again the result is simply 0, so acceleration is 0, which we have mentioned here in this point. So you can say description or the calculation of this particular point second is somewhere here. Then again in this case obviously you can see that you have the area under the curve, which is a rectangle ABCD. You have a rectangle ABCD. So obviously the area of the rectangle ABCD will give you the displacement. And when you will simply do the calculation, so simply you can say that V into T is nothing but the displacement which you are representing by D or S. In few books you will see that they are representing by D, and in other you will see that they are representing by S. So this is what we have as far as the area under the curve is concerned and the displacement is concerned. So S is equal to V into T, which is nothing but the area of the rectangle. And again, as we have all discussions here, the ultimate conclusion is that the body is moving with constant speed. So when you will have this situation and the body is moving with constant speed, you will draw a graph like this. So this is the second situation. The third situation is that the body is moving with a constant acceleration. When the acceleration of the body is constant, so what will be the situation here? Here, first of all, when you will observe the data, time is passing, obviously all equal intervals of time, but obviously in this case the velocity is increases. And what is the rate of increase? So simply you can say that every time here we have 10 meter per second increase in the velocity. Yani if you have A is equal to V minus U divided by T, so what you can say for the first step that the velocity initially is 0 and now the velocity is 10, the time interval is 1, and 1 minus 0 obviously is 1, so 10 divided by 1 will be 10 meter per second square. Here remember this thing that this is the difference of velocity, and when you will divide this difference of velocity by t, you will get this value, which is nothing but the value of acceleration. But one very important point to remember and note is that the slope of this line is always constant. For any change, yani if you want to calculate the acceleration for this step or for this step or for this step, every time you will see that the change is same, yani 10 meter per second. So the time over here is same interval of 1 second. So what you will get again and again, you will get the same value, yani acceleration is constant. Slope is constant means acceleration is constant. So what is the observation? Simple observation you have like this: graph line is a straight line with increasing velocity with time. Increasing velocity with time. You have a straight line. So as I said that the velocity increases with 10 meter per second. Here you have the positive gradient. Obviously, if when you will calculate this gradient, this is basically you can recall the formula of the gradient or slope, which is m is equal to y2 minus y1 divided by x2 minus x1. So in this case, obviously y is velocity and x is time. So when you will calculate this, you will get the positive result, yani positive acceleration, which is nothing but the 10 meter per second square, and we have calculated for one of these step over here. In this case, the third point is again very simple. Area under the curve is a triangle in this case. And obviously the triangle is ABCD. Over here you have this triangle. So area under the triangle will give you the displacement. So when you will calculate this area under the curve, you know that what is the area. So simply you can say that area of the triangle is given by half base into height. So simply you can say that half base. What is base? So you can say this time, and here you have the velocity thing. So when you will use this formula, you will get the result, and this will be the area under the curve, which is nothing but the displacement. So what you are actually calculating here, half into 5 into this value, which is 50. So 5 into 25, and this will give you 125 meters. So this is important. Here again, actually in this case, even you can calculate this value. So here you have 20 multiplied by 5. So this is how much? 0 and 100. So this is what you have in this case. So this is 100 meter. So what is the situation over here? So simply you can say that the value is 50 in this case, maximum value is 50, and the time is again 5. So when you will use these informations, you will get the value of the displacement, which is nothing but 125. Again, this is just one example, but this point is very important, and you have to remember that whenever you will get the velocity time like this, the area you will calculate with this formula. Obviously the result may be different according to the information given, and the gradient you will calculate this way, and obviously the velocity will be different, so the acceleration may be different. But the point is that the acceleration is the positive gradient, and in this case is 10 meter per second in our example, but as I said that you may have different values, but this is important that the positive gradient means positive acceleration. Then you have the fourth situation where the body decelerating. In this case, what will happen, or what is the basic concept of the deceleration? So when the velocity decreases with time, we have the deceleration of the body. So in this case, what we observe that at 0 second, yani when we have not started the you can say stopwatch, the time was 0, and at that moment we observe that the velocity is 50. But once we are moving forward, yani after 1 second, we found that the velocity becomes 40. After 2, we found that the velocity becomes 30, and so on. So when you will draw these values here for VT graph, what you will find and what you will get, obviously the time is here in second. So what you will get here, you will get a graph like this. So the first value is maximum over here, and the last value is minimum, yani 0. So when you will calculate the acceleration thing, yani slope, you can say, v minus u divided by t. So what is the situation here? The velocity, final velocity is 0, initial velocity is 50, and the time is 5 minus 0. So minus 50 divided by 5. So what you are getting? Minus 10. So this is minus 10 meter per second square. And you know that when you have the negative sign with acceleration, this is nothing but deceleration. Obviously, when you will go to the higher classes, you will find another description of this thing, but at least for you, negative means the negative a means the deceleration. So what is the graph this time? So simply you can say that the graph is a straight line with decreasing velocity with time. Velocity decreases every time. And what are the results you can say? So simply you can say that the first point what we are observing is that the velocity decreases with 10 meter per second. 10 meter per second each time there is a decrease. So del V is always same, and obviously this is nothing but 10 meter per second. Then as I said that the gradient is negative gradient, so the deceleration in our example is 10 meter per second square. But obviously with different values over here you will have different values of A. So actually what you have to remember, not the value but the point. The point is that negative deceleration means or negative acceleration means the deceleration, and this is nothing but the negative gradient of the graph which will show this you can say result. Then again here you have the area under the graph, which is basically again the area under the triangle. Over here you have this triangle, you can say this is OA, or as we have discussed before that this is ABC. So when you will consider this triangle, you will see that the displacement you have, which is again positive displacement, yani displacement is still positive. It means that the body is moving from one point, suppose somewhere here A, and the body is moving to another point. But what is happening? The body is displacing in the positive direction. So the displacement is positive, still the displacement is positive, but obviously as the velocity decreases with time, so ultimately the body will stop somewhere here. So this is very, very important, that the displacement is still in the positive direction, and the area again when you will calculate you will get the same result as before, yani half TV. What is half T? 5, and what is V, which is nothing but 50. So the result will be again 125 meter, which is positive. So remember this point, that the displacement again coming as positive displacement. But the overall situation is that the body is decelerating. So when the body is decelerating, your graph should be like this. I hope you are getting my point. If you are new on this channel, so subscribe this channel, like and share this channel with your friends so they can get the benefit out of it as well. And if you have any problem, just mention over here and like this. So when you will subscribe, obviously the other lectures which I will upload, the other you can say solutions of the problems which I will upload, you can see, and obviously this will help you a lot. So as far as this situation is concerned, we have the body is decelerating. Then fifth possibility is that the acceleration is changing, yani the body is moving with changing acceleration. In this case, we have two possibilities. One is that the velocity increases with time, acceleration decreases with time. What does this mean? So here you will see that when we have a curve like this, so what your observation is, first of all you can say and see that with the passage of time, the difference of the velocity is decreasing. So this is what we have, the increase in velocity with decreasing rate. Here you have the first you can say change, here you have the second change, third change, and so on. So you can say and see that every time the change is decreasing. When the change is decreasing, it means that when you will calculate the acceleration, this is nothing but the del V over del T. So this will come as the acceleration decreases with time, because every time this delta V is different. And what different? Less than before. Yani this delta V is greater, this delta V is lesser, this delta V is greater, this delta V is lesser, and so on. So what is happening when you will draw the tangent over here? This is another way to describe the same thing. When you will draw the tangent, basically you will get the acceleration, and you can see that the tangent over here is, or slope over here is the greatest, and the slope is decreasing. So what is happening? Acceleration decreases. So this is very important, that the velocity increases, but the rate of increase of velocity decreases. So simply you can say that the acceleration decreases with time. But this is the situation where you have just opposite, yani the rate of velocity increases with time. So here you can say that the first change is less, the second change is more and more and more. So what you can say, that each time the acceleration is greater than the previous one, because each time delta V increases. Is it clear? This is very important to remember, that each time what we are observing, this is a very small change, then we have a bigger change, and so on. So what is happening when the velocity changes with you can say greater rate? So what you will say, that the acceleration obviously is changing, and changing with greater rate, velocity is changing with greater rate. So velocity increases with time, so the acceleration increases with time in this case. And if you want to show with the help of the gradient, this will be the situation, and you will say each time as the gradient increases, this shows that the acceleration increases. So this is what we have as far as the point 6 is concerned, and this is the you can say the ultimate situation. Obviously in your past papers they will give you one or two or all of the graphs, some you can say in some way or the other, or one way or the other. So this is which very important to remember all these graphs, and all, if you can remember these graphs with their conclusions, this will be you can say a good preparation for the velocity time graph. Inshallah, in the coming lecture, which I will upload next after this velocity time graph, we will solve the displacement time graph and velocity time graphs MCQs. So 15, 16 MCQs we will try to solve, and inshallah this will again help you a lot. So if you have any problems, please mention over here. And if you are new on this channel, subscribe this channel. This will help you. And obviously like, if you like, obviously just mention that you like this discussion, and share with your friends as well. Till the next lecture, take care. Allah Hafiz.